Kia Year 12 and Year 13 and Year 11, I'm going to start recording some of the questions from last year's scholarship calculus paper. So this one is question 4c, which is a little simultaneous equations problem. And I've already highlighted it a wee bit. We have to find all the solutions for x and y, both real and complex, in this system of simultaneous equations. So let's write the two equations out and just notice what's going on in the system. We've got x squared plus y squared, which I don't like, but then I've got 3x plus 3y, and I can already see that this is probably going to factorise out quite nicely. In the second one, I don't like the xy term, but again I've got 4x plus 4y is equal to 2. There are lots of ways that you can proceed here, but what I spotted was that I've got an xy here, and I've got an x squared plus y squared up here. So if I complete the square up here, some good things might happen. So let's call this equation 1 and this equation 2. As usual, there are lots and lots of ways that you can go. I'm just showing you the way that I did it and what I noticed first. I can rewrite that x squared plus y squared as x plus y, all squared, take away 2xy plus 3 into x plus y equals 8. So what I'm doing here is I'm starting to transform the whole thing into a two-equation system where the variable is x plus y as one whole thing to start me off. The next equation now fits nicely into columns, so we'll write things out like that. So x plus y plus 4 times x plus y is equal to 2. So that's equation 2. We'll call this equation 1 dash. If I multiply this one through by 2, I can get matching up coefficients here and eliminate the xy, which I would very much like to do. So we'll write that one out just as is. Now multiplying this by 2, I get 2xy plus 8 times x plus y is equal to 4. So we'll call that equation 2 dash and 1 dash. Adding them gives me x plus y squared plus 11 times x plus y is equal to 12. And now I've got a little quadratic. So we'll let u equal x plus y and we'll solve for u. U squared plus 11u minus 12 equals 0. U plus 12 times u minus 1 is equal to 0. So that gives me, going back to x plus y is equal to negative 12, or x plus y is equal to 1. So we'll work with this one first and we'll come back to x plus y is equal to 1. Go all the way back to the start and look at your two equations. Either this one or factorized version of it. So we've got xy plus 4 times x plus y is equal to 2. So now we can substitute in xy minus 48 is equal to 2, giving me xy is equal to 50. So we've got xy is 50 and x plus y is equal to negative 12. Two variables and two unknowns. I'm going to rewrite x as negative 12 minus y, and then I'm going to substitute that into here. So we get y times negative 12 minus y is 50, and we're going to have another quadratic to solve, but not a very hard one. Negative y squared minus 12y minus 50 equals 0. So one of the tips that you should have picked up by now is never ever work with a quadratic where the coefficient is negative, unless your brain is really, really good. I will always muck that up. So always multiply it through to get a positive coefficient. Now, taking a quick look at that, we're going to get two solutions here for y. And I could go and do quadratic formula, but I want to get an exact solution. So I prefer, definitely don't do quadratic formula on your calculator. You don't want a decimal approximation. You're doing scholarship. So I'll do completing the square, but I know some of you won't. Some of you will do quadratic formula, that's fine. So we get y plus 6 squared is equal to negative 14. So here come my two complex solutions for y. Y is going to equal negative 6 plus or minus the square root of negative 14, which is negative 6 plus or minus root 14i. So that's y. And now I need to just get the x values for that. So what's x? Well, we had that x was equal to negative 12 minus y. So x is equal to negative 12 minus negative 6 plus or minus that. So x works out to be negative 6 minus or plus root 14i. So I'm doing that a little bit quickly because I'm figuring if you're watching this video you can process that pretty fast. But let's write down our two combos here so that we're really clear. So we've got x is equal to negative 6 minus root 14i. Y is equal to negative 6 plus root 14i is the first solution. And then the next one is going to be the other way around. So we're done now with the x plus y is negative 12. Let's go back up here and see what's left. All right, well, we've got our two solutions, so that one's done. And now we've got x plus y equals 1. So again, we're going to have x is equal to 1 minus y, or you could do it the other way around. Substitute into xy plus 4 times x plus y equals 2. And that gives me xy plus 4 equals 2. Xy equals negative 2. 1 minus y times y is negative 2. And so on. So I get y minus y squared plus 2 equals 0. Y squared minus y. I'm sure everyone has turned off the sound by now. That's fine. Factorize that. That's an easy factorising one. So this is going to give me my real solutions. So y is equal to negative 1, or y is equal to 2. X is equal to 1 minus negative 1. So you can see again, if these are the two numbers, the x's are going to be the swap overs. So 1 minus 2, which is negative 1. So we get two more solutions, 2 and negative 1, and negative 1, 2. So altogether we've got 4 solutions, 2 real coordinate pairs and 2 complex ones. So let's just write them out for the sake of it. So 4 solutions, xy equals 2, negative 1, 2, Okay, thanks for watching. Please let me know if any of that's not clear or if there are any things you want me to go over, and I can do that either over email or in the comments.